All right, we're talking about our last point of concurrency now, which is our centroid, and it is created with medians. So let's look at this one. We're going to solve problems by applying the centroid theorem. So in a triangle, a median is a line segment with endpoints that are a vertex of the triangle and the midpoint of the side opposite the vertex. Every triangle has three medians that are concurrent, and that point of concurrency is called the centroid. It's always inside the triangle, never outside. Unlike our first point of concurrency at the circumcenter where it could go outside, this one's always inside. Okay, so, and they don't have a picture for us, so I'm going to draw us a picture of what that looks like. So here we go, we got a triangle. Oh, that's a terrible triangle. Okay, here's a triangle. This one is made up of, it starts at a vertex and it goes to a midpoint. And here is a median. That is the median. Okay? And if we connect all three medians, they will meet up at a point of concurrency. So let's see. The medians of a triangle intersect at a point called a centroid. That is 2/3 of the distance from each vertex to the midpoint of the opposite side. So that is really cool. 2/3 of the distance. Okay. All polygons have a balancing point or center of gravity. This is the point at which the weight of the region is evenly dispersed and all sides of the region are balanced. The centroid is the center of gravity. This is why this point is my favorite point. As an engineer, I love that this is it's useful, super useful. It's the center of gravity. So we're going to go ahead and we're going to see this one. Let me go grab my engineering program here. Okay, there we go. Here is your centroid, right there, point G. So I've connected all of the vertexes of this, or the vertices of this triangle, to the opposite midpoint. And you've seen that they've all joined up at point G. And then I have measured all of the segments leading up to G. Okay, and they're all labeled. And you'll see that the segments that are on the side of the midpoint are half the length of the side leading up to the vertex. So for instance, GC here up on top is 5 units long. GD is 2.5. So GC is twice as long. That means that G is 1/3 of the way from D and 2/3 of the way from C. If that makes sense. Okay. All right. Now, it doesn't matter where I stretch a point around to, it will do that. So now look from E to G and G to B. We've got 2 units from E to G and 4 units from G to B. Now remember, these may not look exactly like double on one side because there's some rounding going on in here, but they are exactly 1/3 and 2/3. Okay, so it's very cool. That's where your center of gravity is. Okay, so let's go see what the math looks like on this. Okay, in triangle ABC, P is the centroid and BL is 6 units long. Okay, so this whole thing is 6 units long. Find BP and PL. Okay, if the whole thing is 6 units long, 2/3 is going to be up here and 1/3 is going to be down here. So BP will equal 2/3 of BL and PL will equal 1/3 of the whole thing. That's kind of the math we're looking at. So the portion that is near the midpoint is 1/3. The portion that's near the vertex is 2/3. So And there they go and fill that in. And they find that PL, oh, they went ahead and just did the 2/3, found that BL was 4, and then they subtracted that from 6. There we go. All right, and then they went ahead and said, how would you do that with coordinates? So you could kind of think that through. We're not actually going to do coordinate math with this one, so you don't have to stress about that. Okay, now you go ahead and try. If they tell us that BE is 9, go ahead and find BQ and QE. Go ahead and pause me and try that. Okay. Did you find that they were 6 and 3? Hope so. All right. Now, in triangle LMN, they tell us that PY is 7. This is 7. Can we find LP? Well, we've already seen what happens with that when we were looking at that other program. Kind of handy. If this is 7, this is going to be 7 times 2. It will be 14, twice as big. All right. And they write it out with a whole bunch more words. And then they do the math for us. But really, it's just going to be twice as long. 14. All right. Now, if SP is 3.5, PZ, how big is that? And actually, I would challenge you, how long is SZ going to be? Think that through as well, because that's the kind of question that Alex will also ask you. Go ahead and pause me. Okay. Did you get that this was going to be 7? And did you go the extra length and say that SZ was going to be 10.5?